now that we've reviewed the different transformations, what we're going to look at is, can we identify the transformations in an equation form? And eventually where we're going is we are going to identify the transformations and graph the function. So it says first identify the parent function, and then we're going to list any transformations that occur. Well, the first function here, in terms of parent function, is the step function, the greatest integer function. The inspirers call it the floor function. It's got the square brackets around the x. And there's actually 4 transformations that are happening on this equation. And I don't know if this will help or not, but I'm going to try. The first transformation is going to come from the negative on the outside of the function. When negative is on the outside of the function, do you remember what it does to the function, the transformation that occurs? And it is reflect over the x-axis. By the way, when I read these, I go from left to right. So I started with the negative. And I know we would read it as y equals negative 4 times the greatest integer of x minus 3 plus 1. But the 4 is separate from the negative when it comes to transformations. The 4 also is outside of our function. Because 4 is greater than 1, this is a vertical stretch. And usually what I write is times 4, by a factor of 4. Well, if we go inside the function, again, because I'm reading the equation left to right, inside the function it says x minus 3. That minus 3 is where the next transformation occurs. And remember, inside the function, it works the opposite way that you think it's going to work. So minus 3 means that we're going to go right 3 spaces. And lastly, we have the plus 1. And the plus 1 is outside of our function. So we're going to go up 1 space. If we look at number 2, h of x equals 9/4 times the square root of negative x minus 6. What's our parent function? Well, it's the square root of x. And in this particular equation, we have 3 transformations occurring. The first transformation is coming from the 9/4, which is outside of the function. So 9/4 here, outside the function, 9/4 is greater than 1. So this is going to be a vertical stretch by 9/4, or 2 1/4, or 2.25. The second transformation is coming from the negative in front of the x, and the negative is inside the function. It's underneath the square root, and the negative inside the function is going to reflect our graph, and this one's going to reflect over the y-axis. One more transformation, the minus 6. Minus 6 is on the outside of the function. And And the minus 6 tells us that we're going to move down 6 spaces. Next to, again, what we're doing is we're identifying our different transformations and our functions. And the first thing that we need to be able to identify are what is the parent function of each particular equation. And on this next one here, our parent function is 1 over x squared. And hopefully for some of you, what you're thinking is, what does that picture look like? Because that's what I do. When I see that, I think, what does that picture look like? And then I mentally draw it in my mind. But there are 3 transformations that are happening to this graph, to this equation. And the first one is, once again, the negative, which is outside of the function. The negative that's completely in front of the fraction is where it's outside of the function. And are we going to reflect over the x, or are we going to reflect over the y? And it's x. And I hope this isn't completely new to you. We did spend a considerable amount of time in Algebra 2 last year talking about this. The next value, I think, is a little bit harder to see. But we have the 2 that's in the denominator of the fraction. And oftentimes what I like to do is I like to write it as a negative in there. Negative 1/2 times 1 over x plus 5 squared. But I found this morning, and I shouldn't have done it, but I found this morning that that was a little bit confusing for people. But what I see when I look at these problems is I see, well, 1/2. Well, 1/2 on this is going to be a vertical compression. So we're going to shrink it by 1/2. But what seemed to work a little bit better earlier in the day is we did this. And that might be better for you. That's where I'm getting the 1/2 from the problem to make it vertically compress by 1/2. And then we only have one more transformation, which is the plus 5, which is inside the function. And it works again in the opposite direction of what we think it's going to do. So we're going to go left 5. Number 4, parent function. Well, our parent function is e to the x. And we actually only have 2 transformations on this one. And the first one is the 3. What the 3 does, the 3 is outside of the function. Because the function's e to the x, so the 3 is outside of it. It's going to be a vertical stretch. But then the question is, what does that 2 do to the function? Because that 2 is the other part. It's inside the function. So what that 2 does, since it's inside, it works the opposite way that we think it's going to work. It's going to be a horizontal compression. Now what's happening is we're given the parent function, and then we need to write the equation. And the thing to think about as you're reading these different problems is, where does it go? Is it going inside the function or outside the function? And as we look at the first function, f of x equals the natural log of x, well, shifted up 2, is that going to be an inside or an outside? It's going to be an outside. And then shifted right 7, is that going to be inside or outside? It's going to be inside. And then lastly, reflected about the x-axis, is that going to be inside or outside? Going to be outside. So if we look at this function here, we've got f of x equals, and I'm going to leave a little bit of space and put my natural log here. Well, the first thing says that we're shifting up 2. Well, that's going to be here. We're going to add 2 to our function. It's an outside of the function. The shifting right is an inside function, and it's going to be x, and it's going to be minus 7. Remember, we go the opposite way that we think we're going to go. And then the last piece here is that we're going to reflect about the x-axis. Well, reflecting about the x-axis means that we have a negative in front of the function. That's going to reflect us over the x-axis. So again, as you're reading these problems, think about, where is it going to go? Is the transformation going to go inside the function, or is it going to go outside the function? If we look at number 6, the parent function now is the cubed function, h of x equals x cubed. And our transformations in this particular problem, vertically compressed. Is that inside or outside? And you can flip your paper over and you see that it's outside. Reflected about the y-axis, it's inside. Horizontally stretched by 5, that's inside. So when we write this, h of x equals, well, we've got our x cubed that I don't want to write down. I'm going to write down the 2/3 there. That's going to go outside the function. I'm going to put in a parentheses here because we are going to have some values inside. And in fact, before you get too far, oops, can't do it, too far ahead of me, I'll scoot my x over a little bit. Because it says that we're reflecting about the y-axis. When we reflect about the y-axis, we're putting a negative somewhere. And we said that it's going to be on the inside of the function. But we're also going to horizontally stretch this graph by a factor of 5. Well, when we stretch this graph by a factor of 5, if we go back to our table on the front, we're horizontally stretching this. What happens is our value is going to be written as a fraction. Because if we look at our note over here, take the reciprocal of the coefficient of x to decide whether it's a stretch or shrink. So in order for us to have a stretch, the value that we have inside our function is going to be a fraction. So we're going to have to take the reciprocal. And when we take the reciprocal of 5, we get 1/5. And then it's x cubed. And go back and look at this once you have it written, because sometimes you get it written down and then you go back and check and go, whoops, I need to fix something. The vertically compressed by 2/3 outside. That seems right. The negative on the inside of the function reflects over the y. We have that. And then the horizontal stretch. Again, we have to take the reciprocal of 5. So we're going to flip that into 1/5. It is going to be on the inside of the function. And then we better execute. So we should be fine on this problem. The parent function is 1 over x, are vertically stretched by 7/2, shifted left 3 units, and shifted down 4 units. And once again, as we start this problem, think about where does the transformation occur? Does it occur on the inside of the function, or does it occur on the outside of the function? And as we take a look at this one, b of x equals, well, it's 7/2. So I'm going to do 7/2. It's outside of the function. That's a vertically stretch. It's outside the function. And then our function is 1 over x. But we're shifting left 3 spaces. That needs to be inside our function. And when it's inside the function, we're going to be adding 3 to our x. And then finally, we're shifting down 4. Down 4 is outside of the function, so it's -4. And let me just say that you might want it written like this. 7 over 2 times x plus 3 minus 4. And just a reminder here that what we were dealing with when we were looking at the transformations, I circled like this. That might be helpful for you in terms of that vertical stretch.